students, great to have you along to look at integration for the second time. Today our topic is looking at the integration of functions of this type, 1 over ax plus b, and we're going to start today with the simplest of those, which is 1 over x, where there's no b and a is equal to 1. So earlier on in the year, you'll probably remember that we looked at a function like this, y is equal to ln x, and we learned how to differentiate y equals ln x by this, dy dx is equal to 1 over x. If you've forgotten that, you want to go back to your differentiation chapter and have a look at that. We learned this. So clearly, if this is the case, then if we're going to integrate 1 over x, then the integral of 1 over x dx must be equal to ln x plus c, plus a constant, because that would drop out when we differentiate, so we don't know what that will necessarily be. So this brings us to a little bit of a problem when we're doing this type of integration, because if you think about the function of y is equal to ln x, you will note that it is undefined undefined for x is less than or equal to 0. It's only defined for x is greater than 0, as you can see on this graph here. However, the function 1 over x is defined for all values of x, barring x is equal to 0, where it is undefined. So we need to think through this a little bit further. Let's do some definite integrals of our 1 over x. The first one we'll have between 2 and 3. Remember, this is representing the area under the curve between x is 2 and x is 3. That is this bit here. And we'll also do the same for between x is minus 2 and x is minus 3, and that will be this bit here. Now hopefully, I know it's pretty poorly drawn, but hopefully you can see by inspection that these two areas are going to be equal to each other, even though when we integrate this we're going to get a negative x in our ln, which is undefined. But what we can say about this area here is it's going to be the same magnitude as this area, but remember what we learnt in Pure Maths 1, that it will be given a negative sign because it's under the x-axis. So that means that we can say that this here is equal to the negative integral of this one here. Now we're going to integrate this and find the definite integral. Well, this is going to be equal to ln x, and because it's a definite integral we forget about the plus c, and we are doing this between 2 and 3. So our next line for this one will be ln 3 minus ln 2, and remember your log rules at this point, don't get confused. This is the same as ln 3 over 2. Next, we're going to do the same with this one here. I'll just give us a little bit more space here. We'll forget about that negative for the moment, we'll come back to that later. If we integrate this, we'll have equal to ln x between minus 3 and minus 2. And so we would write this as ln minus 2 subtract ln minus 3. Okay, so this will give us ln, and this, using our log rules, tells us we've got minus 2 over minus 3, and we can simplify that to ln 2 over 3, since minus 2 over minus 3 is the same as 2 over 3. Okay, now we get to the final point here. Let's consider what is going on here. These are not the same value, but remember what we said earlier, that the area under the curve here was going to be the negative of the area under the curve here because it was under the x-axis. Well, let's see if that's true. What is minus ln 2 over 3? Well, it is equal to minus, big bracket, ln 2 minus ln 3. What is that equal to? Negative ln 2 plus ln 3, which is equal to ln 3 minus ln 2, and that is equal to that. Going back to the integral of 1 over x between minus 2 and minus 3, we want to remember and keep in mind that there is no such thing as ln minus 2 or ln minus 3. They are, ln is undefined for this area. So what we tend to do when we are writing the integral of a definite integral for something like 1 over x or something 1 over ax plus b, what we tend to do is use the modulus sign to indicate this. So for integrating this, we would say is equal to ln modulus x and what will happen here is it will this modulus sign will give us ln between 2, so this will be ln positive 2 minus ln positive 3, which is ln 2/3, which is the same area that we found earlier when we were using our negative numbers. Okay, so use the modulus sign when you're doing definite integrals. Now what we've learned here can be extended. We've used 1 over x. Now we can extend what we've learned to this. The integral of 1 over ax plus b, anything of that form, dx, is going to be equal to ln, 1 over a, this bit here, multiplied by ln modulus ax plus b plus c. At this stage you might be wondering, what's this 1 over a business? So to help you understand that, why don't we go back to an example like this. Let's say y is equal to ln 3x plus 1. And when we differentiated this, we found that we were going to have 3 multiplied by 1 over 3x plus 1, which is equal to 3 over 3x plus 1. So when we integrate it, that is why we're going to take, it'll be 3, this bit here, times 1 over the a, which is the coefficient of x, ln 3x plus 1 plus c. And you can see that that will take us back to what we've got there. That's the reason for that. Okay, so let's now try a few examples from the exercise. First with a few indefinite integrals. So this one here, we will simply say is 1 over 2, 1 over a, where a is 2, ln modulus 2x minus 1 plus c. And we have to say the range for which this is true. Well, it's all values of x except 1. X cannot equal 1/2, since if it's 1/2 in here, even with the modulus sign, you're going to end up with ln 0, and ln 0 is undefined. We'll try this one here. Should have my integral sign in here. So this will be 2 multiplied, the 2 from here, multiplied by 1/2. This is our a here, ln modulus 2x minus 1 plus c. 2 times 1/2 is simply 1, so that's our final answer here. Again, I need my integral sign here. minus 12, so is equal to minus 12 multiplied by 1 over 9 times ln 9x plus 16 plus c. So this is simply minus 12 ninths ln 9x plus 16 plus c. And the value for which x can be for this one is, well, it can be anything, but x cannot be minus 16 over 9, because if it were, we would get ln 0, and ln is undefined for 0. Okay, moving to these ones here. Here we have some examples of definite integrals. This one here is simply this one, so we can chuck that in our square brackets, ln 2x minus 1. We don't need a plus c because it's going to be taken out with a definite integral, 5 and 7. So this will be ln 14 minus 1, so ln 13 minus 2 times 5 is 10 minus 1, so ln 9. We can say this is ln 13 over 9. With this one here, we'll put our big brackets in. Looks to me to be, oh wait a second, made a bit of a mistake there, minus 4 times 1 over negative 2. This is our a value here, and we're timesing by minus 4, ln modulus 7 minus 2x, and this is between minus 6 and minus 4. Minus 4 times 1 over negative 2 is simply positive 2. So we're going to have 2 ln 7 minus 8, which is 7 plus 8, so 15, minus 2 ln 7 minus 2 times minus 6, which is positive 12, so 19, which is going to be, I think that's right, 2 ln 15 over 19. And that is how we do those ones. Okay, now we're on to question 3. This is the more of a word problem solving type approach here. We are told that we need to find the area between this curve, the x-axis, and the y-axis, and x equals 3. So this is the bit that I'm trying to find here. I've drawn the curve. As you can see, the asymptote is at minus 3 here, and we're really dealing with this bit over here. So we're going to say, well, this area is equal to the integral between 0 and 3 of 1 over 3 plus x dx. Our next line, we're just going to chuck this into ln 3 plus x into this here. We don't need a 1 over a here, since a is 1, 1 over 1 is 1. This simply becomes ln 3 plus 3, 6, ln 6 minus ln 3 plus 0, 3, which is equal to ln 6 over 3, which is equal to ln 2. And hopefully that makes sense to you. Well, that brings to a close all of the material that we need to be familiar with to do this exercise. I think one of the questions, I think it's 5 maybe, might be a little bit tricky for some of you. Do have a go, see how you go with it. If you do get stuck, let me know and I'll help you with that as well. Good luck, guys.